Hi, this is Mrs. Blake, and today we're going to talk about molarity, which is one of the many solution calculations that you will run across in a chemistry class. Concentration is the amount of solute divided by the amount of solution, and molarity is just one of the many calculations that you will run into to calculate the concentration. Percent by mass, parts per million, parts per billion, percent by volume, molarity, molality, density, and mole fraction are all considered to be solution calculations. Molarity tends to be very, very common used in chemistry, and that's why we're taking a look at it specifically today. When we take a look at molarity, molarity is a capital M, and molarity is the moles of solute divided by the liters of solution. Molarity is unit specific. In other words, you must use moles and you must use liters in order for it to be considered to be molarity. And you must use a capital M because molarity has a very close cousin known as molality that already uses a lowercase m. So if you write a lowercase m, you're actually saying something different. So let's take a look at this concept of molarity. And again, molarity is going to be moles of solute divided by liters of solution. So when I take a look at molarity, it is going to be some number of moles per, technically, 1 liter of solution. Now, molarity as moles per liter becomes much more functional than molarity as a capital M. And in chemistry problems, I never use a capital M. I always change it to this moles on top and liters on the bottom because that makes it much more friendly. When we take a look at it as moles per liter, it works very much like a molar mass would do in a gram to mole conversion. So sometimes you're given a problem and they give you the number of moles and the number of liters, and you just divide. But frequently in a chemistry problem, you will be given liters, and frequently in a chemistry problem, you'll be given moles and asked to find the other. In other words, they'll give you a molarity and you'll have to use it. If I use molarity as a conversion factor, as moles per liter, it works much easier because I know that if I'm doing a calculation, I want to get rid of liters, and molarity is moles per liter. So I'm going to have some number of moles per 1 liter, and that's going to allow my liters to cancel out and leave me to be able to calculate for moles. Now, with these chemistry calculations, remember anything on top is going to be multiplied by, anything on the bottom is divided by. And if I'm given moles and I'm given a molarity, same thing, the setup of my problem, I know that moles would go on the bottom, and that would mean liters would be moved to the top, and I know in 1 liter there is going to be some number of moles, which is going to be given to me as in molarity, and this would cancel out moles, and this would leave me then with liters. So when I'm using a calculation, if I treat molarity as moles per liter, I end up with a conversion factor that works much better than if I'm just trying to use this capital M. So let's see how that works in an actual chemistry problem. In chemistry problems with molarity, you're going to be given 2 numbers. It is a 3-part equation, and I know that molarity is moles per liter, and I have to have 2 of those to be able to solve for the one unknown. So that when I'm taking a look at a problem, how many liters of 4.00 molar solution could be made if you have 8 moles of solute? Well, I'm going to take a look, and I have 8 moles of solute, and I have 4.00 molar solution. Well, my first step is going to be taking that 4.00 with a capital M, and I am going to change that into 4.00 moles per 1 liter of solution. Now it's going to become much more friendly for my problem. So first note, when I'm taking a look, you are going to never start with molarity. So if I'm never starting with molarity, that leaves me with one choice. I'm going to start with this 8.00 moles. I know that if I start with moles, that means that moles needs to go on the bottom. And that would mean for molarity, if this is my molarity, I know that liters would go on top. And it is some number of moles per 1 liter of solution. And in this case, they tell me it's 4.00 moles. And that means that moles are going to cancel. And I'm going to have liters that are left. I multiply across the top, I divide by the bottom, and I'm going to take 8 times 1 divided by 4, and I'm going to come out with 2.00 liters of solution that I would need to make for this particular problem. So let's take a look at another example. So how many moles of sucrose are dissolved in 0.250 liters of solution if the solution has a concentration of 1.50 molar? Now, if I take a look at it, again, I have two numbers. I have 0.250 liters of solution, so there's my volume, and then they're going to give me 0.150 with a capital M. And again, I am going to automatically change that to a 0.150 moles per liter, and now it acts like my conversion factor. So never start with molarity. That leaves me with 0.250 liters of solution. And when I set up my problem, I know liters needs to go on the bottom. If I'm using this molarity then, it means moles will go on top. And molarity is going to be 0.150 moles per 1 liter of solution. Liters cancels, and that's going to leave me with moles. So I multiply across the top, and I'm going to divide by the bottom. And when I do this calculation, I am going to come out with 0.0375 moles. Now, molarity problems would not be bad if I just deal with these three pieces, molarity and moles and liters. But unfortunately in chemistry, moles is not a unit that's generally measured in very often. In fact, in lab, I'm not going to generally measure solids in moles. I'm going to measure solids in a mass in grams. So I would have to convert those grams to my moles in order to be able to use the problem for molarity. Another frequent abbreviation or another frequent bypass when I have to take a look at this calculation is that 1 liter is an awful lot of a solution. And so very frequently in lab, you're not going to be measuring with 1 liter, you're going to be measuring with milliliters. And so very frequently, another conversion you have to make before you can do a molarity problem is that in 1 liter, there's 1,000 milliliters. Now, lots of people just move a decimal place, and that works fine for me, but you have to use liters if we're talking about molarity. So let's take a look at a couple problems that look like this. So what would the concentration of a solution formed when 1.0 grams of NaCl are dissolved in water to make 100 milliliters of solution? And this leaves me with two different things. First of all, I have 1.00 grams of NaCl. And one of my steps has to be to take the grams to turn it into moles so I can solve for molarity. So let's just take that step and do that right now. I have 1.00 grams of NaCl. And that means grams needs to go on the bottom so it can cancel out. And this is going to be a molar mass. And I know that it's grams per mole of NaCl. And it is 58.44 grams of NaCl in 1 mole of NaCl. That, of course, will cancel out my grams and leave me with the moles that I need for my molarity problem. So when I punch those numbers into a calculator, I am going to come out with 0.0171 moles of NaCl. So now I have the moles I need to be able to plug into my molarity problem. So What else do I have in the problem? Well, I am going to have 100 milliliters of a solution. And again, milliliters can't be used. It needs to be liters. And you are welcome to just move a decimal place, but I know that there are 100.0 milliliters. I know milliliters would need to go on the bottom, and that would mean liters would go on top so they can cancel out. And according to the equation on the top, there is in 1 liter, there are 1,000 milliliters. So basically, I am going to divide this number by 1,000, and I am going to end up with 0.00, oops, forgot my one, 0.1000 liters of this solution. Now I can take a look at my molarity. Molarity is moles divided by liters. And while I couldn't do this to begin with grams and milliliters, I now can plug in my moles of 0.0171 moles, and I can plug in my liters of 0.1000 liters. And when I punch those numbers into the calculator, I'm going to end up with 0.171 with a capital M, which is molar, or you'd still be okay if you just left it at moles per liter. So let's take a look at one more example. How many grams of calcium hydroxide are needed to produce 500 milliliters of a 1.66 molar calcium hydroxide solution? And wait, this problem can kind of throw you off because it's asking for grams. But remember that in a molarity problem, as long as I have moles in a molar mass, I can turn it into grams. So that when I'm taking a look at this, that's a step that I need to do at the end. So what do I have to start? Well, first of all, to start, I have 500 milliliters. And I can't use milliliters, so my first step is going to be to take this 500 milliliters, and I'll put milliliters on the bottom. That puts liters on the top, and in 1 liter, there are 1,000 milliliters. Again, if you just want to move a decimal place, that would work just fine. And I'm going to end up with 0.500 liters of solution. Then they give me a molarity. So I have 1.66 with a capital M. But I know that this works better if I turn it into 1.66 moles per liter of solution. And if that's the case, then I am going to start with my volume. And I have 0.500 liters. That means that liters needs to go on the bottom so it can cancel out. And if I'm using that molarity, that puts moles on the top. And the molarity is going to be 1.66 moles per 1 liter of solution. And I'm going to cancel out the liters, and that's going to leave me with moles, which is not what my question is asking me for, but it's a step closer. So when I punch these numbers into my calculator, I am going to multiply the top, I'm going to divide by the bottom, and when I punch these numbers into my calculator, I'm going to end up with 0.83 moles. Well, I'm not done with the problem yet because I need to take those moles and turn them into a mass in grams that the question is asking me for. So one more additional step is I am going to take those grams of 0.83 moles, and I'm going to turn them into grams, and that uses a molar mass. So this is calcium hydroxide. I have moles, and I know in a molar mass it's in 1 mole of anything, and in this case calcium hydroxide. I can add things up on a periodic table. I'm going to come up with 74.1 grams. And I can multiply that out, and I'm going to come up with 61.5 grams of calcium hydroxide. So, with molarity calculations, moles divided by liters. But frequently with molarity calculations, you have to take grams and turn it into moles, and liters, milliliters, and turn it into liters. So watch your units. Thanks for watching.